I'm Danielle, and I want to talk about my 3M Young Scientist Challenge project. Around the world, there are millions of people who have brain-based diseases, both neurological and psychiatric. This number has risen, unfortunately, during the COVID-19 pandemic. However, there are no genetic blood-based tests to detect biomarkers for these diseases. Through the 3M Young Scientist Challenge, I learned a lot about innovation, but mostly I learned how innovation requires resilience, and that when you hit an obstacle, you have to realize that it's not a straight path. You have to find ways to circumvent those obstacles, and that's what innovation is really all about. You have to stretch your way of thinking and be creative. From my project, I learned a lot about the importance of collaboration in a scientific setting. One reason why collaboration is so important, I've realized, is that you need to be able to access other materials that you may need to benefit your own project. For example, through my mentorship, I was able to access and meet with the brilliant 3M scientists who operate the high-performance computing cluster at 3M. And this high-performance computing cluster was invaluable to my project because it greatly maximized the efficiency with which I completed the tasks I needed to get done. If given a chance to redo my project, the thing I would change is the time at which I looked at the data set. I would have focused on the data sets that I wanted to use for my final project earlier on and scanned them in greater detail. As the final event draws near, I'm very excited about the opportunity to present my project. However, I'm also very focused on the tasks at hand. And now I'd like to thank my mentor, Ms. Sarah Frisco, and the computing engineer, Mr. Gabe Turner, for all of their help with my project. I'd also like to thank 3M for this wonderful opportunity to expand my knowledge about science. And now I will move on to talking about my project via an infographic. For my 3M Young Scientist Challenge project, I wanted to explore my scientific interest in the brain and neuroscience and combine it with AI. About this time, several months into the pandemic, we were hearing of sharp increases in psychiatric and neurological illness, so I decided to read about medical research in some of these illnesses. I learned that generally there are not blood-based biomarker tests that allow for diagnosis and choice of treatment intervention of these illnesses, although they constitute about 70 million cases on the US alone, and an estimated annual healthcare cost of $1.5 trillion. I also found that the medical technique EEG, which measured electrical activity in the brain, could potentially be paired with artificial intelligence algorithms. So I set about the objective to create neural biomarkers to be measured with EEG combined with AI in order to make a system that could perform automated diagnoses and precision treatment interventions of brain-based illnesses. On the bottom of this slide, you can see how the system works. Electrical signals representing brain's neuronal activity is amplified by contacts on the scalp, and these complex set of electrical signals is analyzed by a deep neural network AI computer code written in a system called TensorFlow. Once trained, the AI algorithm can perform automated diagnosis of a new patient's EEG brain electrical rhythms. In the case on the right, each dot you see plotted represents one patient's EEG, and you can see the algorithm has separated the healthy versus unhealthy affected patients with a 91% accuracy. Further, the patients with the illnesses cluster into multiple subgroups that may allow for the more precise assignment of treatment interventions. This is called precision medicine. I am creating a software platform to aggregate the data and different AI algorithms I have designed and tested, and this would allow distribution eventually of these algorithms for further medical research and eventually clinical use. I believe EEG is a greatly underutilized tool in clinical medicine, and by combining EEG with accurate deep learning models, I believe many lives can be greatly helped by improving the lives of the many people who suffer from these brain-based illnesses. Thank you very much for listening. You can learn more about my research on the project website prettybio.ai, which will be launched as part of the final project.